This is a first class recording for Primary Math 4. We are going to have three things today to talk about. First, I'm going to introduce myself, and then we'll talk about the weekly plan for your student and for you with Singapore Math. And then we will also talk, of course, today about the first week's assignments and all of the things that you'll need to have available and plan to do with your student the first week. As a way of introduction, my name is Brenda Barnett, and I am the founder of Singapore Math Live. I began Singapore Math Live just this year. This is 2015 in the fall. This is a brand new thing for me, but I encountered Singapore Math Live when I started homeschooling my own children. I encountered Singapore Math when I started homeschooling my own children back in 2001. My background is I grew up in Oklahoma. I went to the University of Oklahoma and graduated with a degree in mathematics. I went and taught high school in public schools for 6.5 years in the state of Texas, actually, and then I have been homeschooling since then. But although I taught high school math, including calculus and AP calculus, when I taught with Singapore, there were several moments when I realized that I was learning something differently than I ever had thought about math before. One time I was in a group of ladies and somebody rattled off a bunch of numbers and I added the numbers together and I said, wow, that's a total of, it was a marriage experience. I said, that's a total of 127 years of marriage experience here in this room. And they all laughed and said, oh, math teacher, no wonder you added that together. And I thought in my mind then, I realized that the only reason that I was able to do that, the mental math skill, was because I'd been teaching my son second grade Singapore math, and I had learned something from teaching him that skill. Many years later, I was sitting next to my son. He was my firstborn, so I encountered Singapore Math for the first time with him. I was sitting next to him, and we were trying to work a math problem. I believe it was in fourth grade math, and I said to him, I could write an Algebra 2 equation, 2 equations, 2 unknown, and I could solve this, but I don't know how to do this in fourth grade math with fourth grade level work. And so I sent him away, and I worked and worked and worked, and he came back later, and I said, here's what we're supposed to do to solve this. And it's a beautifully simple solution, but I was taught so much to think about algebra and equations that I didn't think logically about mathematics. And so again, my appreciation for Singapore Math deepened. And then more recently, as I've been teaching online, I teach some SAT math prep classes, and my daughter, who's now in the 6th grade, would sit behind me and be in the room when I'm teaching the classes. And one day she brought me her Primary Math 6 book, and she said, Mom, look, this problem is just like what you talked about in the SAT class last night. And I looked, and sure enough, the things that she was doing in her Primary Math 6 book were absolutely the same thing I was talking about in my SAT prep class. Not that Singapore Math 6th grade is a high school level class, but the thinking skills that are important for college entrance exams are the same kinds of things that we're preparing our students to learn in Singapore Math. So those are three very short stories, but those are kind of the microcosm examples of why I love Singapore Math, why I think that Singapore Math is an excellent preparation for your child, foundationally for mathematics and even just thinking skills for life. So I love Singapore Math. I love the fact that technology allows me to be in my home, teaching you in your home, and working you and walking with you through the math and the skills that you need to have. The way Singapore Math Live is set up to work is that I will each week, as part of Singapore Math Live, sorry, I'm going to get this up here, SML for Singapore Math Live, what I will offer you and what I will do is every week I will have the class, like what I'm going to do today, and in the class, some of you will attend live, some of you will attend just watch the recording later, but in the class I will discuss a lot of things. I will talk about what is hard for the week that is coming, what is essential to cover, because there are some things you don't have to do every problem on every page, although if you're home with young children and you need to keep them busy, it's a great way to spend your time. And so that's a good thing, but I'll tell you what's essential to do. I'll help you know how to verbalize what is being said. I'll help you know how to visualize the math and how to show your students how to visualize it, and that way you'll know in advance how to help them do things that they are being assigned for that week. You will need to print the syllabus that is listed on the website, and you'll have that available to you all year long, but encourage you to print it out and have it handy. From the syllabus, you're going to assign the pages. It's a week-by-week syllabus, and you can choose to assign by the day, or you can choose to assign by the week. And that's basically just on your student. Does your student need to have, this is how much you accomplish today, or can you just say, hey, sometime this week, get it all done? And either way you want to do that, of course, is fine. I strongly encourage you, after your student is done with their work for the day, to check their answers and to go over mistakes before the next day. And here is maybe an interesting paradigm. When I worked on Singapore math with my children, I basically just said, do these pages today, and they sat down and did them. I didn't sit down and teach them first, because the way Singapore math is written is very visual. It goes straight to the next thing. And for the most part, my kids were able to just sit down and do the next thing. If we're finishing decimals and starting with fractions, maybe you discuss fractions with them for the first time. But to a large degree, we just started out and had them do it. And then I would go over the mistakes that they made. Again, I think the curriculum does an excellent job just handing them the workbook and letting them start working over things, and they're able to catch on from there. And then you check with the answer keys you have and go over the mistakes before they do the next assignment. If there's a time that you're working and you can't figure something out, there are the solutions recordings. Now, the solutions recordings are not for every problem in every book. They are the word problems. Every word problem in the intensive practice book and every word problem in the word problems book are solved on a recording that I make, and you have access to that recording from the web page. It'll all be there, and you can just click on the recording and see that. So if your student comes to you and they're stuck on number 6, whereas I had to say, okay, son, go away and I'll figure it out and come back and spend 20, 30 minutes sometimes figuring out a problem. That's a little embarrassing, but it's true. You can simply, without sending them away, you can just simply go to the computer and click on the recording link, fast forward to the problem that you need help with, and find the solution right there explained in front of you. And then, of course, the last thing that I would suggest that you do each day or each time, and I'll just put that on this other page for the sake of room, is make notes about your questions. And we can talk about those in the beginning of each class if you're doing a live, or you can email me and we can talk about that. I can send you emails about it or whatever. But if you have questions and they're not answered in the class and they're not answered in the solutions recordings, I would be happy to talk to you about those, and we can email or call or whatever. There's lots of ways to connect, even texting, and we can do all of that. So with that in mind, let me make sure you have my contact info. My phone, I don't mind calls or texts. My phone for that is 832-630-3321. I am in the Central Time Zone, so if you're calling or texting early or late, you'll just need to know what time zone I'm in. And then as far as contacting me, the email address is very long, but hopefully it's memorable. It is simply my name with a dot in the middle, brenda.barnett@singaporemathlive.com. Long to write, hopefully easy to remember. So keep me close and contact me often, however often you need help. I certainly want to know, and I need to know as I start this out, what it is that is helpful to you, what it is you need to know, where my families are having questions and all that kind of stuff. I absolutely want to help you succeed. So let's stay in touch and make sure we can do that. So when you are working with your students and you assign them the pages, and you're not necessarily sitting down with them, they're just starting it out working, and you're available. And so then the point here would be that I would help make you prepared to be available. One other thing I want you to know before we start, and that is what I call my walk and crawl analogy. And I think it's a very crucial thing for parents to understand, and especially if you're helping a student that's starting out, even in primary 4, if you're starting out in the upper years, I think this is a very helpful thing for them to understand and for you to understand as far as not giving up and persevering in Singapore math. If you look at a 10-month-old who's crawling around on the floor, they're very fast, they're very proficient crawlers, they're very good at it, and let's be very stereotypical and say that everybody's going to walk at 1. And so this baby is around here crawling around at 10 months, and so then they get to be 12 months old, and they discover that they have feet for a reason, and they're going to start learning to walk. And so they pull themselves up on their feet, and they take 2 steps and they fall down. And then they pull themselves up again and they take 2 steps and they fall down. And what used to take them about, 2 seconds to crawl across the room, they're now spending a tremendous amount of time walking across the floor. But you never have to tell that student or that child, look, I know it takes you a long time, but you've got to learn to walk. They just intuitively know that they need to learn to walk. And they intuitively know that they have to do that it's going to be better for them to walk. They never stop and say to themselves, I don't know why these people are walking. It's a lot faster if I just crawl. So I'm just going to keep on crawling. And we never look around and see a 16-year-old who's made a decision to continue crawling because it was faster. Every child, whether it's 12 months or 22 months, every child at some point realizes that walking is the way to go. And mathematically, I strongly believe that my personal math education taught me to crawl and never encouraged me to learn to walk mathematically. I learned the skills to do it, to do math. I did not learn the skills to think mathematically. So as you're working with your student, you may have an education like I did, and you may have to, in a sense, unlearn some things or spend the time walking 2 steps and fall and stand back up and walk 2 steps and fall and stand back up and do it over and over. And you're going to feel like it's the slowest thing in the world. But I promise you, it's best for your student to learn to walk, even if it's slower at first. And I'm specifically mean the mental math in this area. It's very important to spend the time unlearning and relearning or learning for the first time the mental math skills that we talk about, because it will really help your student to walk mathematically instead of crawl all their life. And I mean that very honestly. With a math degree teaching AP Calculus, what I learned from Singapore math made me feel like I was finally learning to think mathematically and do math differently. And this analogy came to me as I was working with other students, that kids want to get to the answer as fast as possible, and sometimes the best way to the answer is to stop crawling and slow down and learn to walk, because it will be so much faster and better in the long run, but that is hard. So in my mind, that is an extremely important analogy, and I really hope that it's one you can embrace and help your child to work through too. So let's talk now about week 1 in Primary Math 4. The first book that we're working with this year is the Workbook 4A, and the first week I assigned exercises 1 through 5. Absolutely, you can have your students work the exercises exactly in that order, or you could, let me pause a second. Let me do a different page. Let's do this. We have 3 books we're working on first semester. There's the Workbook 4A, the Intensive Practice 4A, and the Challenging Word Problems 4. That's just one book. And you should hopefully already have your books, but these are the US editions for this one. And the only Challenging Word Problems book these days is the Common Core edition, which is actually identical to the US editions that I have purchased in the past, with very, very minor changes. So in my opinion, this is a marketing ploy to put Common Core on the cover, but we'll leave that to the Singapore math people to figure out. The workbook is the beginning. It introduces the material in the workbook. So that's the easiest book that they have. And many people only know about the workbook, which is why some people think Singapore math is an easy program. The intensive practice book is deeper practice. And it has regular problems and word problems in the intensive practice, and then the challenging word problems are completely word problems, obviously. No surprise there, but they're all word problems, and they go from easy to hard, and then there's a challenging section. And so in any given week, you may be working out of any combination of these books. Second semester, we pick up the 4B workbook and intensive practice. But I would certainly say you want to work through the workbook before you get too deep in the intensive practice, because the workbook is the easier and the introductory level material, and then the intensive practice takes it and gives you more intensive practice in the material. So any given week, again, I don't assign what days you should do it because I don't know what day you're going to go visit grandma or go to the dentist or go to the zoo or whatever. But during the week, sometime the syllabus tells us that during, like, for example, week 1, you're going to do in 4A, you're going to do exercises 1 through 5. This is in the workbook. In the intensive practice book, you're going to do pages 1 through 8. And in the word problems book, you're going to do pages 1 through 9. So now I wouldn't say, okay, we'll just start in the intensive practice and do those 8 pages first. You can do them concurrently. You might have a schedule that says we're going to do exercise 1 on one day and then exercise 2 from the workbook, and have your child do it exactly like you could figure on a 5-day week. That'd be fine. And it doesn't hurt to start the intensive practice the same day. You might want to put that off a day and say, well, let's do page 1 and 2 and 3 and 4, 5 and 6, 7 and 8. And in the word problems book, we're going to do the first part of the word problems is always the examples. And I strongly encourage you to take the word problems and go through the examples with your child. And so the examples are page 1 through 3. So you might just say on the first day, what you will sit down with and could sit down with your child and do are the word problems examples, just so that they've seen how that works. And this particular set of assignments is a little bit different because we start the challenging word problems in the middle. Let me see how that would work out. So we might say that do pages 4 and 5 on this day, page 6 and 7. Sorry. On this day, page 8 is another set of examples to do with your student, and then page 9 would be that day. So this could be one sample week. If you consider this Monday through Friday, you could do it this way, but you don't have to. That would just be one way to set it up. If you're not going to do school at all on Fridays, you got something else going on, or you're going to the zoo or whatever, you could certainly put things in a different order, put it in different places, and work it out that way. I would say that it's not as long as it looks, really, to do all this work. Possibly it looks long, I don't know. But the material in here would certainly be something I think you could accomplish in 1 week. So that would, when I give you this on the syllabus, this is what the syllabus tells you. You can break it down into whatever grouping makes sense to you. Maybe something like this, maybe not. So, all right. So in the workbook, what I'm going to do now is talk through some of the information in the workbook and what you're going to assign, what you're going to see, make sure that things are not confusing to you, the parent. So if your student asks you a question, you're able to answer them. I will tell you things like this. Place value is a very simple concept, but it is extremely important for the use of mental math. And so in the first few pages, when you're working on place value, you want to make sure that you have that your student takes it seriously and understands it. They're going to feel like it's very easy. That's a good thing. Feeling like math is easy is a benefit. And so we want them to feel like it's easy on some level. And I also would tell you on page 8, when you're writing words out, watch out for the use of the word and. Sometimes people say 2080. I'm looking at 4A. 2080. No, in math, and means a decimal. Now we don't have any decimals in this section. We're not going to decimals yet. So when they write that out, they need to write 9,215, not 9,215. They're just writing the words, the numbers themselves with the place values. So there should be no and in any of those problems. Okay, so make sure that when your student is working on that, they don't put an and. All right, so then on page 9, I'm just going to highlight a few things I want to make sure you understand. On page 9, we have the problems like 2A. So just to make sure the instructions are clear, on 2A, when it gives us a number 23,529, we want to make sure that the 2 stands for 20,000. And so that's going to go in one of the blocks. The 3 stands for 3,000. The 5 is a 500. The 2, the digit 2, stands for 20. And the digit 9 stands for a ones unit of 9. So it looks a little odd. What are we supposed to write down? But the value of the digit 5 is 500. We're just trying to make sure that we all understand what that is asking. So when you go on over to page 11 and it asks you some questions, it has the idea of a digit and a value. So in part, we'll just look at 1b, the digit 2 is a digit. But then you go on down to say the next part of that says the value of the digit is 200. So make sure you're clear on just very basic whatevers, but the idea of the digit and the value, sometimes that can cause us a little bit of pause, not a big deal, but make sure we understand what's going on. All right, on page 12 and 13, which is exercise 4, is our first bump in with mental math. And so as the parent, I want to make sure you understand how we're doing mental math, because again, it may be especially new to you. If your student has done Singapore math, this will be a review, but if you're new to Singapore math, let's talk a little bit about how we do these kinds of problems. When we see 7,000 plus 9,000, we are not trying to line them up and add them vertically. We want to think in terms of 7,000 and, or plus I should say probably, let's keep off the word and, 1,000 plus 9,000. So really all we're doing is adding 7 and 9. Now when you see a 7 and a 9, what a Singapore math student would do would be to think about 7 as being 6 and 1, and then 9 and 1 come together to make a 10. So what we have is a 10 and a 6, and that gives us 16 thousands. Okay, we want to be able to look at this and realize that the place value makes this 7 and 9 is 16, and we have 16 thousands. All the way down there, when you're adding things together, you're always doing it to make a 10, and when you make the 10, you've got the place value there. So on part C, I'm sorry, row to B talking about C. Let me get my stuff together here. If we're looking at part C on that same problem and we have 18,000 plus 6,000, 18 needs 2 more to make a 20. So the 6 could be broken down into a 2 and a 4. So that gives me 20,000 and 4,000, or 24,000. Now, it might take us a little bit of time because I only grew up thinking about addition this way. I always went right to left. But when I taught myself to think about tens, and I made the 6 into a 2 and 4, so I'd have a 20 and 4 more, it becomes a lot faster, although I have to stop and teach myself to think that way. What about mental math subtraction? If you're going to subtract with mental math, again, 13,000 minus 4,000, we're not really worried about the thousands. Okay, we just need to think about 13 minus 4, the TH for thousand, so we're just not worrying about that. And Singapore math would tell you to think about the 13 as a 10 and a 3. That's 13. If we're going to take away 4, I don't have enough ones. So to get rid of 4, I'm going to take it out of the 10, because in the earlier math classes, because we're starting in primary 4 here, we spend a lot of time making sure we know that 6 and 4 make 10. And so if there's a 6 left over and I have the 3 left over, then that gives me 9 thousands for my answer. So memorizing 13 minus 4 is 9 is really not as beneficial as having a 13 be divided into 10 and 3. It's taking the 4 out of the 10 to have 6 left and making it 6 plus 3 is 9. Again, it takes a long time to say it. It takes a while to get used to it. But when you do get used to it and you can think in terms of tens, it makes things go very, very speedily. Sometimes you don't have to worry about, just like other subtraction, like on part D, if you have 54 thousandths and you're going to subtract 21 thousandths, you can think about 54 as being 5 tens and 4 ones. Just use a stick for a 10 and a dot for a 1. And you can subtract 2 tens and 1 1. And that gives your student the visual of what we're doing when we say there are 3 tens and 3 ones left over, or 33 thousandths is the answer when you subtract. Again, we're not going right to left and subtracting. We're using the idea of what a 10 and what a 1 is. Again, if this is the first time you've seen mental math, Singapore style, this might be a good thing to spend some time on. Some of you may just fast forward through the recording because you've done it this way a long time, and that's okay. So we have 40 thousandths, subtract 16 thousandths. If you have 4 tens, that's 40 thousandths. If I'm going to subtract 16, I'm going to take away 1 10, and of this one, I'm going to think of it as 4 and 6, because I'm going to take away 6 thousandths, and that gives me 24 thousandths, or, of course, 24,000 left over. The idea is always to go back to a 10, and to start with the 4 tens, subtract the 10 and 6 ones, which leaves me the 4 left over. All right, what about mental math multiplication? It's the same idea, of course. If we start with, like, for example, we have 8,000 times 6. If 8 times 6 is 48, then we have 48 thousandths. Okay, you can just think of, this box has 8,000 in it, and I have 6 of those boxes. So what I have is 48 thousandths, or 48,000. And every time we're doing math, we're just thinking, making it as visual as possible in our head, and coming up with, without having to write and put it vertically. And so again, right to left math is now out of vogue. We don't want to do right to left. We want to think about math left to right. Part D, for example, if you have 14,000 times 3, if you have a 10 and 4 ones, and you do that 3 times, then you have 3 tens. This is in thousands, right? 3 10,000ths, and you have 12 thousandths. And look what happens. The 3 and the 1 become another 10, so that gives me 42 thousandths. And we go there. Now, again, this is why I'm teaching parents in these classes and not the students. That's way too fast to introduce it to your student if I was teaching them directly. But working with the parents, you can learn to take a 10 and 4 ones and make it something that they would benefit from. And they can take this idea, this picture, rudimentary as it is, and realize, okay, that's 3 tens, and the 12 ones make 4 tens with 2 extra, giving us 42,000. Mental math division is a little more, I don't know, something to work on, again, instead of just making a division sign and doing it. Thinking of 8,000 divided by 4. What I want to do with this is to think of ways that I can divide 8 thousandths into 4 groups. And so if I think of 8 thousandths, and I'm going to very conveniently, this is 8 thousandths. Each of those is 1,000. And if I divide them into 4 equal groups, I have 2,000 in each group. You can show that a lot of ways. You could show that this is 8 times 1,000 and divide each of those into 4. There's 2 of those. Okay, there's 2 thousands in each one of these. Actually, I don't like that picture. I'm going to do it a little differently. That's going to get confusing later on. I think it's better just to stick with the idea that it's 8,000 divided by 4 is 2,000. And the mental math idea is the fact that these zeros can be thought of kind of as lumped together as a group. And we don't really have to distinguish between them. We don't have to divide with those there. You really can just look at that 8 divided by 4 is 2. They all know that. And we're talking in terms of thousands, so it continues on into thousands. If you have 72,000, like on part B, divided by 6, here's how I would show that. Sometimes it's helpful to regroup it. And I'm going to take 72 and make it into things that are easily divisible by 6. If I have 60,000, I can divide that by 6, and that's 10,000. If I have 12,000 divided by 6, that's 2,000. Each of those are easily divisible by 6. And then that tells me altogether that that's 12,000. 72,000 divided by 6 is 12,000. Again, if you're starting Singapore math in the 4th grade, this is a big leap for mental math. Your student may never really get all the way to mental math, and you may struggle with it yourself. If you've started back in 1st and 2nd and 3rd grade, it becomes easier. But this is a kind of thing that if you can help your student to begin to think about numbers this way, that you can break a number down. You can say that 72,000 is the same thing as 60,000 and 12,000. So think about this. This is just a big box, and in my big box I have 72,000 items. If I want to divide it into groups of 6, into 6 equal groups, I could take it and say, well, I'm going to put 60,000 in the top half, and I'm going to put 12,000 in the bottom half, and as long as I divide it into 6 equal groups, one of those columns is going to be 1/6. It's going to be 6, divided by 6 would be one of these columns. So if I take 60,000 divided by 6 and 12,000 divided by 6, then it's going to work out and tell me how much I have altogether. So 72,000 divided by 6 is 12,000. It breaks it down just that way. And so this skill, this idea that you can take 72,000 and take it into 2 groups that are easier to deal with mentally, and then find divided by 6 that way, again, it's going to feel like you're trying to walk as a toddler, but if you can teach your mind to break numbers down into convenient groupings, mental math will not be a problem. Okay, and as you go through, and as your student goes through and does practice, mental math will become easier and easier, and that's a good thing. Number 14, or page 14, is the last part of this particular book assignment that we're doing, and I just want you to know that it tells us that rounding, it makes it very visual, which is good because although rounding is a simple skill, for some reason it just gets confusing with students when they round. So I like the fact that Singapore Math makes it extremely visual when they round. You can see on part 1A that 47 is closer to 50, and so when you round it, you're going to round it to the nearest 10. So if you'd look at the 10s, 30, 40, 50, 60, it's closer to 50, so you round to 50. And then the only thing you have to teach them is that if you're at the halfway mark, you always round up, of course. And so that works out that way, and I think the rounding, it's an easy skill that's very, very important to learn and be comfortable with, and definitely start with a visual way of learning that. Moving on to the intensive practice book, This week in intensive practice, we're going to assign pages 1 through 8 for the students to accomplish. We're going to start on these pages, and again, it does place value, it does it visually, it helps you to see the value, so that visual math, being able to visualize what's going on, is very important. So visualizing place value, what does it mean to say that you have $20,007? The fact that all the values, the place value helps you to line it up is extremely important. But all of those are pretty intuitive, and you can work on that. I think one thing I want to draw out and draw your attention to is actually on page 3, number 6C. It talks about the number 89,093, and it wants to know what number is 100 less than that. Sometimes when you have to break through a thousands barrier or whatever, it gets a little confusing. What I want your student to be able to do is to look at this number and say that's 890 hundreds. Okay, we often say 200, 1200. We don't very often say 312 hundreds. We call it 31,200. But this is 312 hundreds, and this is 890 hundreds. So the problem here says, what number is 100 less than 890 hundreds? That would be 889 hundreds. And of course the 93 follows. So if you lose 100, if you start with 890 hundreds, then you go to 889 hundreds. That's how you, when you want to go 100 less, it moves that way. So helping your students to begin to look at numbers, not just the way it says it, 89,093, but also in this way, 890 hundreds, going down to 889 hundreds, is a really good and helpful thing. Moving on to page 4, this problem talks about the number 69,996, and breaking it down into the 6 is 60,000 and that first 9 is 9,000. That part is fairly simple to do, but I think the sentence part of the question is worth pausing and thinking about a little bit, especially because it begins to help us learn how to interpret sentences with words into math information. So helping your student break it down this way: the value of 9 in the tens place. Those are a bunch of words, and we want to be able to interpret that. What is the value of 9 in the tens place? That is 90. The 9 in the tens place has a value of 90. And then the question is that is, uses the word is, and anytime you see the word is in a math sentence, it always translates to an equality. It's making it an equal sign. My name is Brenda Barnett. It's an equal sign. It's an equating myself with my name. So 90 equals how much less than, so here's our second sentence. Less than the value of 9 in the thousands place. What is the value of 9 in the thousands place? Okay, now how much less than 9,000 is 90? That's what it wants to know. 90 is how much less than. You might even use change to smaller than. Smaller than equivalent is something a word we use more than less than when we're just talking about things. 90 is how much smaller than 9,000. Now, when we talk about less than, it's a subtraction problem. In subtraction, the order matters. So basically, we're setting up an equation like this, which, by the way, could be an algebra equation, but it's so concrete in this sense that we don't have to make an algebra equation, make variables with it. What do you have to subtract from 9,000 to get down to 90? Now, again, if you've done PM4 math for a while, you might look at that and know right away that we're going to have to take the thousands and the 900s, and it's going to go down to 8,910. We certainly don't want to line it up vertically, if at all possible. You could think of 9,000 as being 1,000 and 8,000, and think of the 1,000 as being 900 and 100. And if you take 90 out of the 100, you have 10 left. So that 8,910 is where I come up with this answer. And it's fast mentally if you can teach yourself to slow down and think that way to solve the problem. Again, we talked about mental math before. It goes on page 5, part 10, like for example, part G. If you have 60,000 and you're trying to divide it into 5 groups, remember that you can take your 60,000 and say, well, that's just like 50,000 and 10,000, and those numbers are easy to divide into 5 groups. 50,000 divided by 5 is 10,000. 10,000 divided by 5 is 2,000, and so altogether I have 12,000. And that's a very concrete way. Again, you can also tell your students, if you have 60,000 people in a room and you put them in a group where you have 50,000 on top and 10,000 in the bottom half of the room, and you want to divide them into 5 groups, then it's very easy to see that each of these groups would have 10,000. Let's go with 10K. And each of these groups would have 2,000. And all together, if you take the entire room and put them into 5 equal groups, there are 12,000 people in each group. Again, we want to make it as concrete as possible so they're thinking about numbers this way, thinking mathematically instead of just always making a division and going through an algorithm or a step-by-step process in which to solve the problem. Number 11, same page. I just want to make sure the terminology doesn't confuse anybody. On part 11, I guess 6 and 7, the sum of the value of the largest digit again, making sure that we have the terminology and the way to take words and make a math problem out of it. So the sum of the value of the largest digit and the value of the smallest digit is what we're looking for. And here's how we interpret that. Sum, your students need to know, means you're going to be doing an addition problem. Then you want to know what is the value of the largest digit. And we're looking, I didn't write it down, we're looking at the number 68,349. The largest digit is 9. What is the value of that digit? The value of 9 is 9 because it's in the ones place. But then we're going to find the sum of the value of the largest and the value of the smallest digit. The smallest digit is 3. What is the value of the smallest digit? 300. So then if you're trying to find the sum of the value of the largest digit and the value of the smallest digit, it's 309. Breaking it down so that you have a good way to talk about those and to help them find those is very important. I would also like to do the next one just again to help you begin thinking. Today's recording is longer than it'll usually be, largely because I introduced myself and all that in the beginning, but let's talk about part 6. Actually, it's part 7. It tells us the value of the digit 8 is how many times the value of the digit 4. Again, we're dealing with this number. What is the value of the digit 8? That is 8,000. And that's how much more than the value of the digit 4? Well, the value of the digit 4 is 40. Now, again, here's what makes this nice with Singapore math. I have 800, actually let me change back to my color, try and color code things a little bit. Here I have 800 tens is how many times 4 tens. Do you see how that makes it very easy to do the division? If I look at this number as 800 tens, and this number is 4 tens, then I find out that I need 200 4 tens if I want to get 800 tens. Again, that may be very foreign to you, but if you show your children, if you use this verbiage with your kids, it will catch on because it makes much sense. We can look at this and think about how many tens do I have and how many tens do I need, and we have much less trouble with place value and the zeros than I do when I try to do it mentally. And I admit I do have to still stop and think much more than my children do because this is the way they learned it first, and that always feels easiest, right? On page 7, number 14 and 15 are the same problems, the same questions, rounded differently. One of them tells you to round, I'm sorry, I start writing and try to write fast, and I get really sloppy. One is rounded to the nearest tens, and one is rounded to the nearest hundreds. And so when you have those numbers, I would ask you to consider rewriting those for your student. You can, there's not much room to do it on those pages, but you could give your student a page and just tell them 692 plus 319 and round to the nearest 10 and round to the nearest 100. And they could do the same thing on one page, 690 plus 320. I hope that they would do left to right and say there's 9 tens, 9 hundreds, and then there's another 100, so that makes 1,000. And when I make 100 of the tens, I get 1 10 left over, so that's 1,010. When I round it to the nearest 100, this becomes 700 and 300, which gives me 1,000, otherwise known as 1,000. And so you could rewrite, or you could ask them to rewrite on their own paper and just do side by side. Again, the point is, so the question's at the bottom, the point is to help them see what is important and how to write that out. And then the next page is factors, and that's just practicing the multiplication and knowing what numbers are work. Let's see, I guess we could look at one of those just to make sure. 17 part C, for example, the number 52. When I look at 52, it's obviously 1 times 52. It's an even number, so 2 times 26 is going to work. A great thing to show your children if they don't already know it. If it is a multiple of 3, in other words, if 3 goes into it evenly, then the digits are going to add up to a multiple of 3. So for example, 52, if you think of it as 5 plus 2 is 7, because 7 is not a multiple of 3, I know that 3 doesn't go into 52. It's a quick way to know if it's a multiple of 3. If I have the number 54, since 5 plus 4 is 9, and 9 is a count by 3 number, multiple of 3 means you can count by 3 and get to it, then I know that 54 is going to go, 3 is going to go into 54 evenly. 3 does not work for 52. It will work for 54 because 5 plus 4 is 9. That's kind of a number theory. It's a great one to know. But 3 is not going to work. 4 does work since this is an even number. I can just divide it in half. I know that 4 times 13 will work. Clearly 5 doesn't work. The only way 6 would work is if 2 and 3 works. And since 3 doesn't work, I know that 6 will not work. And so actually this ends up being all the factors of 52. Once you get past the halfway point and then you know you're done. 5 doesn't work, 6, 7, 8, you're past the point of anything working. Certainly once you get to 13, you know it doesn't work. So the factors of 52, 1, 2, 4, 13, 26, and 52. So those are all the pages assigned in the intensive practice book. The word problems book, keep in mind all of the word problems are worked out on the solutions recordings, which you can access from the website. You're doing page 1 through 9. Usually I don't do anything in word problems. One more thing I want to talk about today. Very rarely do I ever say that Singapore Math didn't do something the easy way, but I'm actually going to say that today, and you may not hear it the rest of the year, but I'm going to say on page 2, their worked example, I want to show you what I think is a better way to do this problem. It's talking about the factors of, to find the factors of 120 and the factors and the highest common factor of the two numbers. If you're just looking for the greatest common factor, in America we call it the greatest common factor. I suppose in Singapore they call it the highest common factor, but GCF is an abbreviation we use. If I take 120, I do this a lot. When I'm breaking a number down, and I go to a prime number. 120 is 2 times 60, and then 60 is 2 times 30, and 30 is 2 times 15, and 15 is 3 times 5. When I get to numbers that I'm only, well, that's just 1 times 3 and 1 times 5, then I know I'm finished. This is called prime factorization. And if I do the prime factoring for both of those numbers, again, this is an even number, so I could just start with, did that one wrong in my head, it's 105. I know that 1 plus 5 is 6, so I know 3 works. You might look at that and say, well, 5 works, and that might be easier, and that's okay too. This is the prime factorization of 210. If I look at these and say, how many numbers do they have in common? They both have a 2, they both have a 3, they both have a 5. So the greatest common factor is 2 times 3 times 5, and 6 times 5 is 30. I think that finding prime factors and finding the greatest common factor this way is an extremely easy way to do it. In the worked example, it actually wants you to find all of the factors, and so to find the factors you have to do what they did, 1 times 120, 2 times 60, but I also want to make sure just from the beginning that you see this skill of starting with a number like this and factoring it down into prime numbers, so when you're finished all of the numbers are prime. That tells us 120 is 2 times 2 times 2 times 3 times 5. That's the prime factorization of 120. Prime factorization of 210 is 2 times 3 times 5 times 7, and very frequently making a prime factorization is a great way to go. Okay, so again, a long recording because there's a lot we want to talk through in all of this. You can see all of the information for the word problems in the solutions recording. And if you have any questions, if this raised more questions than it answered, if you have anything you want to discuss, send me an email, send me a text, and let's talk through it. Thanks for joining me, and I will have another recording for you for the second week.